for this very nice introduction. You started from long ago. I'm very honored to present today at DiSC finally. I was looking forward to it. And I'm very excited to present with very interdisciplinary audience as well. It's kind of my first time with such an interdisciplinarity in the room. So my name is Marica, and this is work in progress. And it's joint work with Team Greece from Bocconi University and Lorenzo Trapani from the University of Leicester. So informality is by its very nature hard to quantify and hard to address with policies. And the irregular migration often provides more people willing to work informally. And this is especially the case in sectors like agriculture, which are characterized by large demands of unskilled labor and seasonal labor, temporary labor. So I show you some estimates here in the slides. About 1/3 of European agricultural workers are estimated to be informal, compared to about 5% in other sectors. And in the context of Italy, where I come from, in agriculture employs about 5 to 10% of the European irregular migrants, of course, an estimate. Concerning Italy, again, this amount of informal employment in agriculture produces value for about 1 point of the GDP, and losses to national revenues of about 7 billion euros due to unpaid social contributions, unpaid labor taxes. So irregular migration and informal labor cause financial and welfare concerns, because there is always the question of the displacement effects also between formal and informal workers, and try to quantify the amount of this phenomenon and the amount of the losses from this phenomenon. In the context of Italy, again, this is a phenomenon especially spread in the south. And in the context of agriculture, this is the case especially for Sicily and Apulia, two regions in south of Italy, where 70% of contracts are informal, versus 30% of national level. So still, 30% of contracts at national level are estimated to be informal. Okay, given this motivation, what motivated then my paper? In this paper, I propose a new way to quantify informal employment induced by irregular migration and identify farms that misreport. I use exogenous variation from a large and unexpected migration shock, focusing on the 2011 Arab Spring migrant wave that hit southern Italian coast. I use rich, very wide data set of farm level data with many farm characteristics and weather variables, about 400, for all farms in Italy. So for all farms, for farms in Italy in all regions. And this data set covers the year 2010, my pre-migration shock time period, and 2011 and 2012, where the migration shock already happened. And then I use machine learning to predict farm outcomes in absence of the shock. So the idea is what would have happened to farm employment had the migration wave not happened. Interpreting the migration wave as an irregular supply of workers, potential workers, and especially informal labor supply shock of a large amount of workers that are willing to work informally, and that might be easily matched with large demands for seasonal labor on farms. How do I identify misreporting? It will come in a few slides, but an anticipation is I will look at predicted outcomes, farm outcomes, and after the shock, and I will identify misreporting as deviations from predicted outcomes after the shock and reported outcomes by farms, so actual data. So from residualized outcomes, where these predicted outcomes will be estimated with data of other farms before and after the shock, and farms that are most likely hit by the wave in these coastal regions before the shock. But no worries, it will come more in detail soon. With also some variable names and numbers. Okay, And then the idea is, if I estimate that there are some farms that misreport, and I estimate some significant amount of misreporting, then what are the economics mechanisms behind? What happens? What are distributional effects of an increase in informal employment due to an irregular migrant wave, an irregular shock of labor? What are the distributional effects of informal employment on prices and profits? And then I will decompose the effects between profits and sales or labor cost, and I will look also the effects on wages. And then doing some back of the envelope calculation, I will also estimate losses to national revenues. So the 2011 Arab Spring immigration to southern Italy came in the aftermath of the Arab Spring uprisings and the Libyan civil war through two main routes. The orange route that hit in particularly Sicily, so in particular only Sicily, and the other route that hit especially Apulia, which is the region here, the heel of Italy. This was a very large, unexpected, unprecedented wave with 64,000 migrants, detected migrants landings, and many more undetected landings on southern Italian coast, and mostly in the first half of the year. So 50,000 in the first half of the year. So potentially a labor supply shock of workers that would have been available for. We are focused on vineyards, so for the harvesting in September. Compared to previous years and previous decades that saw instead about 4,000 landings on average between 2009 and 10, and so also for 20 decades before that. I interpret this migration wave as a large informal labor supply shock, was large and unexpected. There were no resources for constant monitoring and for detection, and Italy was in such a bad condition that in February declared a state of emergency. So the government allowed extra resources and extra funds for facing the emergency, and especially setting up police detection on the coasts and first aid migrant camp and detention centers. Because in Italy since 2002, migration, so irregular entry, irregular migration is a crime. So if you are found to be without papers, you are put into prison and then expelled. So there are a lot of incentives for migrants entering Italy irregularly, like without papers or without regular entry, to avoid camps and work irregularly for money and forged documents. Because typically migrants don't want to stay in Italy, but they want to reach further destinations in Northern Europe and Germany or France. In agriculture, the organization of informal labor, of migrant labor, of foreign labor, but also of native labor, but just informal, is very often organized through mafia-type systems called caporalato, where you have a caporale, which is a gangmaster, that matches the large demand of farms, or large demand for unskilled, ready available, well, large amount of informal labor, cheap labor, and the supply of a lot of people willing to work informally. People typically group in the squares of the village and say, today we need 50 people. Who wants to join? You raise your hands and then you go on the truck, and the caporali, so the gangmaster, allow this match. And more than 400,000 people are estimated to be part of this system in Italy, and are mostly undocumented migrants, actually. But this is something that we will not be able to identify in this paper. We will not be able to say if informal work displaces incumbent native work or other migrant work. It will just be a displacement between formal and informal labor that we'll be able to identify. And then there are anecdotal estimates of migrants disappearing from first aid camps that are located on in the landing regions. And an estimate for 2011 is that about 21,000 migrants disappeared. So they were registered when they entered the first aid camps, and they lost track of them. So how to identify informal employment due to the migration shock? So I look at labor productivity as my main outcome, defined as grape quantities, tons of grapes, divided by labor hours, reported labor hours. And given the quantity, if you would underreport labor hours, you would observe an abnormal increase in labor productivity, not explained by farm characteristics or changes in inputs or weather variables. The labor productivity, why labor productivity and not hours directly, is because labor productivity is very easy to predict, also after checking with machine learning methods. You can really well estimate a mapping between farm inputs and weather variables to labor productivity, something pretty mechanical, and it's very easy to predict for years, for many farms in Italy, and also for farms in the landing region, in Sicily and Apulia, before the shock. And the idea is then to identify, to use the estimated function, but let's just say it more theoretically, is to use the estimated labor productivity in absence of the shock, the counterfactual, and to estimate gaps in labor productivity, so to residualize the reported outcome with this prediction, and to observe and to look at whether the difference between what you report and what I estimate is significantly different, is abnormally large. There is a part that is noise, and there is a part that, given your characteristics, it should not be there. And I identify this, what should not be there, as I will show you also later. Okay. Farms may underreport the quantity. However, we claim that this is unlikely. If you're producing low-quality grapes, you typically sell wholesale, right? So you sell in big markets, and they pay you a minimum price. If you produce high-quality grapes, typically buyers want certainty with written contracts, like quality guarantees with written contracts that guarantee certain quality level. So it's very unlikely, and there is not much anecdotal, or not at all, for what I know, anecdotal evidence for underreporting. Even if they would underreport, then if I observe a spike, then I would estimate a lower bound. And another important thought that I gave, and I assume also that labor productivity of informal does not differ of labor productivity of formal labor. You can imagine that informal labor might be less motivated or might have less effort, but especially in the case of this irregular migrant wave and migrant work, so the working times are really long. So because of fatigue and exploitation, you might think that the labor productivity of informal labor might be lower than labor productivity of formal labor, in which case I would also estimate a lower bound. So other important assumptions behind the displacement, identification of displacement effects of formal with informal labor are that the two are very substitutable, right? So if a big migrant wave comes to DiSC, so if they don't know much about machine learning, then they will not be replacing Matthias, right? So, and the idea is that since on the farms you need a lot of, ChatGPT might also do the job, as we were talking before. So in the case of farms, especially vineyards, typically there is large demands for unskilled labor, and whoever is available, ready available and cheap, is employed for harvesting jobs. Then I assume that there is no effect on migration shocks on capital, on assets, and other farm covariates. So most migrants arrive within June, and the harvesting is in September in 2011. So at least for that short term, I think that this assumption is very plausible in the short term, as the wave was unexpected. And then there is this no spillover assumption, right? So what if happens if some migrants go to other regions? I mean, if they go in block, right? If they would really cause a shock in other farms, in other regions, that I use as a comparison unit also for the landing regions, for farms in the landing regions. Well, then if I would still would be a lower bound, because if their productivity in other regions will be also inflated by the arrival of informal labor, then I would compare similar outcomes. So that would be also lower bound. But it's also very unlikely, not just because if you run around Italy without papers and you're black, you typically are stopped and you run the risk of expulsion. So there was no organized relocation of these irregular migrants, and all the first aid and the detention camps were in the landing regions. And asylum seekers, so those who want to fill out an application for becoming refugees, right, for having asylum. they were not moved in mass in other regions. They were moved compared to the population. Plus, these refugee seekers, asylum seekers, don't have big incentives to risk to lose the application because they are going to work informally. Plus, they receive some pocket money by the state while they're waiting for the response. And they had received a house. So people applying for asylum seekers, we don't expect that they are those actually going to work informally on whatever field, because they receive money, they have health insurance, at least for the time that they're waiting in some residence provided by the government. And the detention centers, where also escapes are very likely, are all located in the landing regions. Data. After some years of waiting, we received some data, representative farm level data for 2010. I have 1 year before the shock comes, and 2011 and 12 for all Italian regions. The source is the European Farm Accountancy Data Network. And I merged this data with a lot of agrometeorological data, controlling for wind speed, humidity, deviation from the type of water in the soil. So there are a lot of very detailed weather data to control for any deviation or weather shock or standard meteorological conditions that can lead to different productivities, different Q especially, but also different hours worked depending on the heat and so on. The treated units, right? So you have the treatment, this migration shock, and the treated units are potentially, like as an intention to treat, potentially all farms in Sicily and Apulia between 2011 and 12. Calabria, the tip, there is no data because vineyards are very, very small and they are not economically relevant. So in this data, only economically relevant farms are included, meaning they produce output for more than 8,000 euros. So it's, you know, almost economically relevant, so many are there. And the sample is about 3,000 vineyards that when you weight them for how much they represent of every of other farms in the sector, they represent about 20,000 vineyards in Sicily, in Apulia, and about 60,000 in the rest of Italy. That's so I have individual observation of farms, and I have a weight telling what how much this farm, depending on output, labor hours, land area. This is mainly the three variables that determine the representativity of the farm. I have this farm, these weights that tell me how many other farms they are representing, right? Okay. And in terms of model specification, I put in everything that I have: land, capital, inputs, size, type of grapes, organic farming, geographic variables, all the weather variables, as I mentioned. So a quick analysis of what happens before and after to quantities and hours, if there is any interest in that, in the sense that on average, everything can happen, right? We always need to condition on factors, but this is just descriptive statistics of grape tons before and after in the treated, in potentially treated farms, so in the farms in landing areas and in the control other regions of Italy. So farms produce before and after in the treated region similar amount of grape tons, about 160, and labor hours is about 4,300, and after there is a decrease in labor hours, right? So this on average. So there is some hint, but this, of course, there are large standard deviations. You need to understand whether any difference that you observe descriptively, once you condition for other changes, then might still be there or not. And in the control region farms, in the control farms, you observe also similar quantity levels on average and similar labor hours level. They even go up a little bit. Okay, you see that in the control region they produce less quantity, as in the next slide I will show, but this is also mainly due to the fact that there are more farms producing table grapes in the treated region. South of Italy, you have quite some table grapes, and they weight more. So it's not that you're producing, but it's just since I have tons of grapes, in table grapes are heavier, so it seems that also in the treated units they produce more, but because table grapes weight more. Here I have some more descriptive statistics on differences between treated and control farms over the whole sample. In terms of hectares, so size, you see that in treated farms, Treated farms are on average bigger, yes, and the land productivity is also higher. Remember that the land productivity does not necessarily explain a lot of the fertility of the soil, because again, if you're producing heavier grapes, right, your numerator is bigger, so you need to control for a lot of things in order to understand really well how farms produce. For instance, capital intensity. So how much machines are they harvesting in a mechanized way, meaning they maybe don't need, right, informal labor if they use machines. So I also control for how much they use mechanical harvesting. And you see that capital intensity is typically bigger in the control farms in other regions. And then you see here that 17% of farms in my treated regions produce stable grapes only, while this is very, very small in all the control farms. And the last line is about grapes for PDO wine only. PDO is for protected denomination of origin. That's a very expensive grapes for the very expensive wine, very, very expensive wine you buy. And then you see that they're underrepresented in the south. They produce less very high quality wine, while in the north you have more. Plus, as I said, I will control for other characteristics and farm types and specialization of the land and weather variables. Okay, now your part. If you don't want to interrupt with questions, I think questions in the end. That's the idea. Okay, it's already 12:24, so I will take 10 minutes more. It's fine. Okay. So the methodology hinges on having a good predictor for untreated outcomes. Untreated means all other farms not in the landing regions and farms in the landing regions before the shock. That's all my untreated, right? Not hit by the shock. I predict labor productivity gaps using a superlearner, which is a convex combination of multiple algorithms. The idea was originated by van der Laan and others in 2007. The idea is that you have many algorithms. You have lasso, you have boosting, you have random forest, you can have OLS, right? You can have standard regression, but you can have super vector machines and neural nets. And from every single learner, you obtain predictions. And then you combine in a very simple way predictions in order to give more weight to the prediction of one learner that did better in predicting it. So you run a regression with all the predictions on the right-hand side. So, and you explain using the prediction from lasso, the prediction from boosting, the prediction from the random forest. You combine them in order to explain the outcome again. And the linear regression, so the parameters that you estimate in this linear regression will be this weight, this alpha, beta, gamma, and so on, will be implicitly reflecting the importance of lasso in predicting. So how much lasso did better than boosting in predicting the effects. And then I will take the feature values from this second stage regression, and I will compute the residual, so my gaps. I have more details, but I think it's very intuitive as a method. Okay, and then the second stage of the estimation is: are these gaps statistically significant, statistically larger in the treated regions than in the control regions? So I will estimate the farm level causal effects of migration instead using a data-driven kernel matching estimator. So I will match firms. So I will compare residuals of similar firms to understand how much of this is noise and how much of this residual is actually abnormal, or how much of this y minus y hat is actually abnormal. And here I give you the intuition of the method. Okay, in the next slide. Okay, in the next slide. First, one more word about what I do with this residual outcome, with these gaps that I estimate. Let's call them delta hat as a yi minus y hat for each farm I. So we expect that pre-migration we have high prediction accuracy, right? So we have a low mean square error for every farm, all for the treated and for the untreated. And especially that the distribution of the gaps of the treated units do not differ statistically from the distribution of the treated gaps of the untreated units, of the untreated farms. So pre-migration shock, I should predict well everywhere, right? post-migration shock in the absence of other technological big shocks in the harvesting industry or other labor market shocks, which I assume. The mean square error in the treated should be larger than the mean square error of the untreated statistically. So that it should be a shift in the distribution of the gaps that I have for the treated units to the right. So the gaps for the treated units should be statistically larger than the gaps for the untreated units. But instead, for the untreated, I should still estimate no difference after migration and before migration in the estimated gaps. And one way to check, to have a number to understand on average how much the gaps in the treated units are larger than the gaps of the untreated units, is to run a standard OLS regression, sort of a difference in difference regression. So regress the gaps on the left-hand side on a treatment dummy on the right-hand side. For robustness, I have some placebo tests to look at whether there may be significant effects also for some control farms. If you cut, then you cut Sicily, you cut Italy, you cut the south, those south, and then you look at whether there might be some regions that have some significant effects. So you do it one by one. Or you can do a leave one out estimation in the control group to understand whether some farms in the control group are driving the results. And then how I estimate misreporting at the farm level, as I mentioned here, we can actually skip to the end because I already mentioned this. I use this causal forest estimator as a nearest neighbor kernel matching estimator. So random forest is a kernel matching estimator, right? You can see it in this way. You assign weights to units falling into the same leaf. And these are similarity weights depending on the frequency with which similar farms fall into the same neighborhood. And let's see if I have time for yes, I think I have time for giving you a quick intuition. So consider every farm as described by a vector of characteristics xi equal to the deterministic vector little x, your characteristic of your farm, of the farm and the weather. I want to estimate the delta of x as the causal effect of the shock on the residualized labor productivity, on the gaps. That is now my outcome, right, the gaps. And I want to do this in a neighborhood for which I can estimate that this delta of x is homogeneous, right? In a group that I know if farms falling into this neighborhood, they will have the same delta of x. And for this, I use the tree to partition the covariate space into binary left and right partitions. And for instance, I start with all observations, and I start splitting, let's say, according to the covariate x, and the value 16 is a random number, such that the delta hat estimated here and the delta hat estimated here, so the variance of the delta hat between the two new partitions is maximum. So such that to maximize treatment effect heterogeneity between the two new partitions. So in this case, not the mean square error, right? Just the delta of x. And then I will continue, using the standard way to cut the trees, and I will build many trees to have a forest, and to use the final partition of the forest to compute weights, right? Weights, similarity weights, depending on the frequency with which every unit is falling into the same neighborhood. And then I will estimate the delta of x. So conditional on is a conditional effect, conditional having the characteristics x by regressing weighted gaps on the treatment dummy post, right? So migration post. So I use the weights in order to match more similar farms. That's it. And then in the paper that I will refer you to, we develop also randomized tests for inference in this specific case that is not sensitive to the algorithmic specification and to the multiple hypothesis testing problem. But I don't have time now for the details, but if you are more interested in the technical things, where typically you do the bootstrap instead to understand variance of your estimates. Okay, and okay, some results now. Estimation quickly, because I also can refer to the paper, but I can estimate labor productivity gaps for untreated data pretty well. Prediction accuracy is about 98% in 2010, in the year before shock. And from the weights, I can see that LASSO and seeing are mostly the only algorithm that give some good prediction accuracy, probably showing that labor productivity is something easy to estimate with a simple parametric actually algorithm. You don't need very complex neural nets or vector machines because you don't have enough data, or because the model is very simple, like the parametric structure of what determines labor productivity follows a simple, rather linear function. And then I guarantee, so I assure myself first, and I knew that the labor productivity of treated farms in 2010 are statistically similar to the labor productivity of untreated farms in 2010. And then doing the prediction exercise on the treated data after shock, I find instead significantly differences in terms of mean and distribution, and here are some tests. Here is a map of my mean square gap, and the darker, the stronger. So you see that the error, so the residuals, the gaps were higher in terms of mean squared gap in Sicily and Apulia than for other regions. And in order to understand whether there is a significant difference, I run a simple regression where I have on the left-hand side, I have the gaps, my delta hat. On the right-hand side, I have a dummy one for farms in Sicily and Apulia after the shock. And here you can interpret as a percentage, and you see that there is about 21%. So the gaps that I estimate in the treated farms are about 21% larger than the gaps in the untreated farm. So the difference is in colors. Okay. And which types of farm misreport the most? So here, go back. I use first this matching, right, during the forest. So I will have a delta hat, big, so uppercase delta hat for every farm, right? Because I have a delta hat of X. So for F condition on certain characteristics, you have a misreporting amount, right? So a part of that gap that is causal to the wave. And I can plot them. So I have a distribution of treatment effects. I have a distribution of misreporting, and this is the distribution of misreporting. You see that the average is also around this 21%. This is for Sicily and Puglia differently. So the average is something around here, but now I have different heterogeneous levels of misreporting for farms. And if you test this statistically, it's clear that there is some heterogeneity. Some farms misreport more, some farms misreport less. Statistically significant for 80% of the farms in Sicily and Apulia. So I can estimate with precision that there is some misreporting for 80% of them. And then the question is, what drives differences in this misreporting? Well, you go back and you linearly project these estimates on farm characteristics in order to explain what. And there you will have to have a little model in mind that a farmer misreports is more likely to misreport if your marginal benefits of misreporting is higher than the marginal cost of misreporting. If your probability of detections are higher, you tend to misreport less. For instance, size. Larger size farms are more likely to be detected. So you see also here the smaller farms misreport more. Farms that have also other crops that probably can invest, so they can use this harvest labor also in farming other crops, they misreport more. And this I found very interesting, like farms in higher altitudes, so less accessible for inspection, they are more likely to misreport. And something also with the number of grape types. So if you are rather producing one type of grape, in particular PDO grapes, so high quality grapes, you are more likely to misreport. I think this is a very interesting result for us economists, because if you're producing higher income products, the marginal benefits, so the marginal rate produced by this informal labor is higher because you're producing something valuable. So you have more incentive to misreport if what you produce is more valuable, given that you have a probability of being detected. So high quality grapes farms misreport more. I do some back of the envelope calculation to transform labor productivity increases into unreported hours and workers using some definition of the agricultural work units of the European Union. And I find that on average farms misreport about 200 hours or 0.3 full-time workers. So 1 in 3 farms misreports 1 worker. Right, so you could see it that way. And how much is this in terms of sector? Well, maybe the absolute numbers don't tell you much. So what I estimate is that the share of unreported hours over reported hours is 6%. And this translates into about 23,000 informal workers in 2 years. So in the 2 years, 2011 and 12, I estimate 23,000 informal workers more caused by this migration wave. And again, informal workers are about 6% of formal workers in 2011 and a bit less in 2012, which I also think that is possible that workers stayed 1 year longer providing informal labor, some of them at least. More than that, there were more migration waves, so then it would really confuse my results if I would expand the data set above 2012. There were many more migrations. In terms of tax and wages, tax evasion, I assume minimum wages of 7 euros per hour, which is also what farms report, and 60 hours in season. And then I estimate 75 million euros of unpaid income tax and social contributions caused by the labor supply shock. This is not huge, but it's just an estimate of the extra amount of unpaid income taxes and social contribution due to the shock. And then finally, the last table is looking at profits, changes in profits of farms that are in the landing regions. So I look at profitability. So I use the same denominator. I use assets to scale it, as is kind of common also in economics. So I estimate an increase of about 6 points on the profits. So misreporting in the treated regions seems to increase profits. And then I decompose the effect. It seems to be no effect on sales. It seems to be mostly driven by a decrease in cost. Well, big surprise. And especially you see labor cost and not much in other costs. I don't find anything on prices, probably because many firms are price takers. So they take the price for grapes. And other firms, the one that produce high quality wine, they can set the price themselves. So they have no incentives in rather monopoly power on a certain type of grape variety. So they don't change it. And I don't find anything on wages, so nothing big, a little bit of reduction of the wages of people, of formal workers, but it's not significant because the wages declared are already very close to the minimum, actually. So that's also why it's difficult to find something low. So you cannot declare something illegal, right? So that's probably why. Okay, some robustness checks, and then I conclude saying that irregular migration, what I find is that irregular migration displaced formal with informal labor. The estimate's about 11 million hours that were not declared, or 23,000 informal workers in 2 years. The misreporting was not precisely estimated, not statistically significant for every farm in the landing region, about 80%, and especially for small farms in more remote areas producing higher quality grapes. And the find higher profits due to lower labor cost, prices unaffected, and here the explanation that I gave you before about growers being either price takers or price setters. And then I estimate losses to national revenues for 75 million euros. More details you can find in the paper. Here's the paper. And thank you very much for the invitation again and for your future comments and attention.